routers and firewalls. So this is purely a networking problem. But it's applicable to this kind of role-based approach. So what's happened there is exactly what I said to sort of set up this role discovery problem. We've had a sort of managing these partner connections. Basically what's happened is every time a new partner comes on board, there's some process where a network engineer goes out to those routers and firewalls and configures them to allow this business partner to have connectivity. Or when we terminate a relationship with a partner, the network engineer is supposed to go in and remove those connections. Well, over the course of years, maybe decades, that stuff has gotten to be a real mess. And it's gotten to the point where, there's lots of errors in it. It doesn't make sense. People don't really understand what the firewall ACLs are doing. If you point at a particular ACL in the firewall, they really can't tell you what it's there for. So they were afraid to remove it or modify it. So this has become a huge problem. And what we want to do is move our entire partner connectivity infrastructure towards a role-based networking approach, which I think is pretty interesting in and of itself. So the idea here is we're going to define network roles that are going to correspond or engineering partners or outsourced customers, and those network roles will be able to be reusable across those different partner organizations, so that we have a much more manageable type system. Well, so they're going, essentially what HPIT is doing is they're going through this role engineering process. They have to sit down with literally this 3,000 times 10,000 size space of things they're working with and try to make sense out of it and design. And so they're going to they're using our role discovery technology. We've built some tools to help them manage the roles, to be able to look at them, to explore them, to annotate them, to compare them, to do various sorts of upgrades, to connect out automatically to our routers and firewalls to be able to retrieve and set these ACL informations. So that's ongoing right now. That should all go live, I think, at the beginning of next year. Then an important customer who we're working with, they're sort of a medium to large enterprise customer. They have approximately 10,000 employees, $2 billion in revenue, so they're not huge, but they're certainly a large company. And they're going through a similar sort of role-based development process for their standard applications. So they have these 10,000 users connecting to something like 100 enterprise applications, but you can get more. Application means something like the HR system or the general ledger or the portal. So these are pretty high-level kinds of things, and you can expand that down into much finer level things that they have to have access to. And their problem is, again, it's the typical kind of role engineering problem. The people who are doing this in this company are a relatively small group of people, and they just simply don't have the visibility into all the different applications that are being run to really understand of what their current access controls are doing. So they really need the kind of help we're providing with the role discovery, and it's been really interesting for us to engage with them and really get honest feedback about how things work and what the challenges it is they are facing. So I just wanted to show a small table of a couple of results just to sort of give you a sense for how these algorithms work. This data is some of the partner connectivity router data. Now there's actually a much larger number of data sets. These were sort of like 3 of the cleaned up ones that we're working with recently. And basically the green part at the top shows you the size of the bipartite graphs we're dealing with. So the number of users in these graphs is between 2 and 3,500 users. The number of permissions ranges anywhere from 1,000 to 10,000. And the number of edges in that original bipartite graph can be as large as 185,000 edges. So these are pretty large graphs that we're dealing with. In our lower bound techniques, we were able to determine that, for the 3 different cases, there must be at least 453, 390, and 172 roles. Now, that doesn't mean that that's the optimal number of roles. That means that the optimal number of roles can't be any smaller than that. The actual optimal number might be bigger than that, but we we can't really tell. But we know that it has to be at least that big. And then we have, using our sort of weak edge lower bound, we have these, which is just the sum of the users and the permissions is the bound on the number of edges. And then the role minimization algorithm is described first, and then we have this edge minimization algorithm. And you can see that the main point is that the role minimization is getting reasonably close, or at least we're comfortable with how close it's getting to the lower bounds we've developed. So, in particular, we're within 3 on the first data set, and within 32 or something on the second, and close on the third. And then when we do the edge minimization, you can see in some cases we get modest improvement in the number of edges at the expense of an increased number of roles. A threefold improvement in the number of edges, which was very promising. And again, with better edge lower bounds, we would have a better idea of how close these things are to the optimal. Okay, so that's just some sample data sets. So next steps. So the thing is, in some sense, everything I've told you is a lie, right? The real problem here with access control is that most organizations' access controls are just too complicated, and they're looking for a way to simplify it. It isn't really that what we want to do is convert existing access control to an equivalent role-based representation. Organizations are trying to figure out how to vastly simplify their access control. That's really the problem they're facing. And so things that we're discovering in the role discovery, while they do good things like identify low-hanging fruit that you can go after in this role engineering process, and they expose this noise in the system to sort of indicate where there might be problems in your existing access control, a lot of the roles that we're discovering become very difficult to interpret to the people we're showing to, so this customer we have and to HPIT. So there's a couple of reasons for that. One is that the noise in the system, these false positive and false negative, fracturing these bicliques in such a way that's bad, that's sort of deriving a set of bicliques that may not be actually semantically meaningful, right? The other problem is maybe these roles are meaningful, but when you discover them, all you know about them is it's this set of users and this set of permissions. There's really nothing else that you can say about them. So there's two possible solutions depending on which problem you think it is. The first would be, I've talked in this talk about developing bipartite graphs. Well, you can easily imagine coming up with approximate covers where you have smaller sets of roles that cover 90% of the edges and maybe introduce new edges that aren't there with a certain percentage. And so we're very interested, and we've been working a lot, especially this summer, on coming up with approximate covering algorithms that'll be applied to this problem. So we're hopeful that'll be useful. There's things like clustering you can do, and there's some other techniques that are useful here as well. Leads more to putting some semantics around the roles is this idea of going from roles to what are commonly called rules in the literature. So a rule, basically the idea here, and this is a little bit different from what a lot of people talk about with rules, but the idea is that for each user and each permission, there's a set of attributes associated with that user or permission. So for users, it's sort of obvious. You have your department, you have your, whether you're a manager or an employee or a contractor, you have grade, or certainly you have your name, address, phone number, your geographic location. There's anything you can imagine that would be in an LDAP directory could be considered an attribute for a user. For permissions, there's less usable permissions, but there are usable attributes, but there are some. So for example, you might have the organization that owns that application, who's maintaining it. You might have, you might be able to classify your applications into types. This is an HR application, a finance application, a user application. And so these roles consist of some subset of users and some subset of permissions. And what I might want to do is use some either machine learning technique or some other technique to sort of relate the attributes of those users and permissions that are in that role to help put some semantics around that role. So I could ideally come up with something like a logical expression that says, okay, this rule corresponds to people in this geography, in this department,